Aloha everybody, this is Gigi from Kauai Community College. In this video, I will be talking about volume by slicing. And this is the third video in this topic, so make sure you watch the previous two before this one. All right, so let's get started. All right, so the question is to find the volume of a solid obtained by rotating the region bounded by the y-axis, the line y equals 2, and the curve y equals square root of x. So what I'm going to do is I'm going to put the grid line up here so I can draw a little bit better. Okay, so there you go. And we are going to go ahead and take a look at drawing the graph here. So we have, say, the y-axis, say right here, y-axis. Okay, excuse my lines. Okay, and then we are going to have the x-axis, and then we're going to draw the line y equals 2. Okay, so I'm going to make this a little bit larger here. Y equals 2. This is the line y equals 2. And then the curve y equals x squared. So 0, 0, 1, 1 over 1, 2, 3, 4 up 2. And you get an intersection right there. Okay. That is that. And then we are going to rotate it about the y-axis, right? So you're going to rotate it about here. So that means I am going to have to go to the other side and do that reflection. 1, 2, 3, 4 up 2. And it goes like that. And to make this three-dimensional, because when you make that rotation, you will get a three-dimensional shape, and its boundary would be here, right there, and make this 3D. You would go like that, right? So that's the three-dimensional shape that we need to find a volume for. Okay, so now suppose then we are going to cut this into smaller strips, right? So just as before, we would take a look at this, and in this problem, it would make a lot more sense when we are slicing it this way, right? So you got to slice it that way, horizontally. That means the limit of integration will go from 0 to 2, okay? Because that would be from here to there, right? And then the thickness of your slice is going to be delta y, okay? And so let's go ahead and draw out the one slice so that we can really think about how to find the volume of one slice. Okay, I'm going to go ahead and take the lines away because I really don't like writing on the lines there. So then here is my one slice. It looks like this, right? So this right here is delta y. The radius now is going to be from here to there, from here to there, which is the, if you think about it, which is the x value of the function that is red right there, right? Square root of x. So if we have y equals square root of x, you square both sides, and x is equal to y squared. And that is this length right here. That's the radius. So the radius would be y squared. Okay. So then the volume of this solid is the integral, and we've already said from 0 to 2, okay, of the area of one slice, which would be the area of a circle, multiplied by how thick. And we know how thick is dy because that's a horizontal slice, okay? And the area would be pi r squared, and r is y squared, so y squared squared is going to be y to the 4th power. And go ahead and take the integral from there. You would have the pi, I'm going to take that outside. The integral of y to the 4th power is y to the 5th divided by 5. We are evaluated from 0 to 2. And so here you have pi, plug it in 2, that would be 32 over 5, because 2 to the 5th power is 32, minus, when you plug in 0, you have 0, and your final answer is that volume of this shape is 32 pi over 5. And that is how that works. That's it for today.